one more topic, theorem of three moment equation. It's also considered as the Clapeyron's theorem of three moment equation for finding the maximum minimum diagonals of the shear force diagram to solve for a complete solution for statically indeterminate beams. So already we have discussed and solved problems how to find the shear force diagram for the minimum diagram for continuous beam. Here we are going to discuss how a fixed beam to be solved by using the Clapeyron's theorem of three moment equation. Fixed beam comes under the statically indeterminate beam because here itself fixed and three unknown. Here also we have three unknown supporting axes. Totally six unknowns are there, but by having three equations we can find all the unknowns. So that we are going for another approach called the theorem of three moment equation. Okay. Since here, take this is a point A, this is a point B. Okay, and it's considered the UDL W per meter. So how to find MA and MB? In the last case, left extreme and right extreme are there, but the moment will be equal to 0. Okay, continuously. But we cannot take not like that. Okay, since it is fixed end. Fixed end means moment must be existing. Okay, so MA is there, MB is there. To find these two things we have to find. For that, we have to have an approach. How to approach this thing? Okay. The approach is nothing but let's consider, okay, AB as a simply supported, okay, and we have to extend this one, imaginary line, imaginary part, okay, imaginary part with a dummy load, okay, dummy supporting action having zero span, okay. Let's take this is A, let's take this is A0, okay, as convenient, and this is L1 let's take, and this is a stake L0, we can zero span, let's take as L0, as well as the support B also to be taken, to be considered as the simply supported, but we have to extend imaginary part, imaginary region, okay, this also L0. Okay, so it is a dummy supports. Okay, here length is 0. So L0 nothing but L0 equal to 0. Here also L0 is equal to 0 only. Okay, so here the approach how to find. So I take this as B0. Okay, B0, and it is UDL. Okay, so first consider A0, A and B. Okay, so segregate the things. It's a dummy one, imaginary part, limit. Okay, and here simply supported with UDL. As discussed, this W has to by 8 will be the W has to by 8, and here is the dummy or imaginary part. Don't touch it. Okay, how can we find these things? Let's go for theorem of three moment equation. How to write? Okay. First, we are having this M A naught. Okay, M A naught into L naught, and this is M A 2 M A into L naught plus L1. Okay, then we have M B. Okay, M B into L0. So we are considering the span A0, A, B. That's all. One region. Maybe at the time we can consider two regions fully. So A0, A, B alone we consider. Now MA0 is a dummy function. Cancel it. This is also cancel it. Okay. Here 6A naught x bar. Here 6A 1 x bar given by L0, L1. So it is dummy, imaginary part, cancel it. Okay. Then here the thing is L0 equal to 0. Okay, cancel it. And here the thing is MB is there, A1 to x bar. So I need to find what is A1, what is x1 bar. Okay, this is nothing but L1 by 2. L1 by 2. A1 bar, that is 2 by third of B into H. Okay, B you know that is L1, H is nothing but maximum moment in the region W by H. Okay, so by substitute here, I can get the value of MB. So MB I can get the value. Okay, next we can move on to, and one more thing, if you do like this is correct. Okay, you just one time pinch it. Okay, so MA not 0. Here AB, so MB comes. Okay, so MB means comes with the distance of L naught, so it is 0 span. Suffer 0. So that we can get the value of MA. Okay. Next we can move on to another region. Another region means this one. AB D naught, because we have to find what is MB also. Okay. So for that we need to rewrite the backwards Theorem of Three Moments equation concerning the concentration. That is AB D naught. Okay. So MA into L1 plus MB, so 2 times MB into L1 plus L0 plus MB naught into L0. Okay, that we are having. So that is equal to 6A x bar by L plus 6A x bar by L, where here A is nothing but A1 x bar, here A naught 1 naught, here this span is L naught. Okay, so now wherever this L naught comes, that comes as 0. Okay, this gets cancelled, this gets cancelled, and this one gets cancelled. Okay, W is just this imaginary region, and I know the values of MA. Okay, MA I know, use it. So MB unknown value, and the A1 is super. So A1 as already we know the same thing here. A1 equal to 2 by third of the BH, and the H1 bar. So by here AB D naught, this AB becomes left side. Okay, AB D naught becomes left side. So X bar will be from here. Since it is symmetrical, anyway this X1 bar equal to L1 by 2 only. So after applying the value here, you can get the value of MB. Okay, so from this MB we can find it. Okay, after finding this value MB and MB, you can go for the find the supporting axis. To find the supporting axis. Now the unknown bending moment, that is intermediate support. Here the MB and MB we have found out. Then find the supporting axis. After finding the bending moment, here are the things of differences. Value MB here, sorry, MA you have a value. Okay, if it comes here and MB comes here. Okay, depends on the value you can put the point. Okay, then there is just this is the complete solution of development where it does not overlap here. So this is negative. Okay, and this is also negative. That means MA, okay, it is negative. MB is also negative. Okay, so MA is negative. MB is also negative. According to the diagram. Then you approach the same value. MA value equal to this much. Okay, and find the minimum diagram by using this one. Okay, you take right side. Okay, from here itself. Okay, take right side. So I am having MB value from here right side. So you have MB value is there, the moment you can take MB and this is minus W into L1 into half of the value L1 by 2. That value equal to MB. Okay, known value is also known value. Okay, and one more thing, support axis. Here RB can have. Okay, having RB value. You have found out. Okay, so RB into here we can write. Here also you have RA support reaction. So RB into L1. Okay, that is support RB into L1. That is equal to MB. Okay, so known values. We have to known value. Find RB. After finding this one, we can know that RA plus RB that is equal to total load. Total load is nothing but having only one load, that is WTL1. Okay, then we subtract WL1 minus RB becomes RA. So from that RA you can find. Accordingly, you can find all the supporting axis and all the amounts have been found out. By using this one, you draw the CFO's values at each and every point. Then finally, you can draw the CFO's diagram with respect to the side dimension. So that's all. You can go for the previous class also to draw the CFO's diagram as well as the bending moment diagram and side dimension how you can use to draw for the CFO's diagram as well as the bending moment diagram. So that's all for fixed beam. Only the thing is we are going to consider fixed end to be replaces the simple supporter and you have to extend for imaginary part to solve for intermediate support because both are at the initial ends only, but it should be considered the intermediate support. Okay, thank you.